Yes, sir.
Okay. So we have discussed different parts of the computer system. For example, memory devices. There are different stages of or levels of memory devices like registers, then cache, then main memory or internal memory, then what external memory. Then we have discussed about what input devices, interconnection mediums like QPI, PCIe, uh, processor itself. That means how an instruction could be executed, or for example, how a program could be executed. Then this program will be divided into different instructions. Each instruction will be executed through one cycle, and this cycle is actually made of what? Different stages like fetch, decode, execute, interrupt, like this. So these things we have learned. And also we know what processor could perform. Processor could perform. That means it will execute one instruction at a time. It could perform arithmetic operation with ALU. But this is the answer of question what? That what processor do. But if I could ask another question, that how those tasks will be performed, what is the answer? That we have learned about what are the functionalities a processor could perform. But another question also could be appeared, that how those things will be organized. They are controlled, okay, so that there is no error, okay, there is no mistake, because there are a lot of tasks, okay. There are different components, they are connected in different ways. So how the things are organized? Okay, so if I draw the microprocessor, so there are different components inside. One is what? Internal bus. With this internal bus, register or internal memory is connected. Then another is ALU, what will perform in arithmetic operation, isn't it? And also there is another component. Would you remember? What is the another component here? That is CO, control unit. And this control unit basically perform the what? Giving commands or giving the sequence, how the task will be organized, one thing, and give the proper commands at a particular point. What is the task that particular uh, device to perform? For example, if it is a keyboard, okay, only thing that it will insert data from user to the computer system, isn't it? Computer system from user. Also, this keyboard could be asked different tasks from the CU. For example, control unit could ask what is the current status of the keyboard. Also, if the computer or processor has initiated this input output task and it is now switched to another program, okay, after finishing this input output operation, this keyboard will perform interrupt, okay. Then your computer will find out this is the interacting device, okay. So these are the different ways this keyboard is connected with your system, okay. And these are the defined tasks, defined steps, which are sequenced, okay, and arranged by your computer system. And your computer system control unit is basically arranging these things, okay, as a supervisor. Okay, so in this chapter we will learn about control unit. Control unit. So, control unit. Okay. Have we got the motivation? That's why we should know about the control unit itself, because it is kind of supervisor, controller of the full system. And here the system is made of different components. So who will supervise those? Okay. After performing a task, those device will give the report. So who is collecting these reports? This control unit is collecting those reports. Okay. Based on this report, based on this status, then it will make another decision from the next step. Okay. Okay. So here I have discussed one thing, that is program is made of different instructions, and each instruction is made of is performed or executed within an instruction cycle, and one cycle is made of different phases. Now, to make the task of control unit easier, these phases are now divided into some unique steps, modular steps. Okay, modular steps, and that will take very small amount of time. For example, one clock pass, for example, to perform that modular task. So it has a special name. This task, modular task, has a special name. What is the name? The name is micro operation. Micro operation. So in short, I could write in this way: micro operation. So if I execute one program, this program is made of a lot of instructions. Instruction number 1, instruction number 2, instruction number 3, instruction number 4. Again, each instruction will be executed through an instruction cycle. And each cycle is made of what? Different phases, different sub-cycles. For example, phase, indirect, execute, interrupt. Okay. Now, I have given another idea that these phases now divide into some modular task, unit step task, that is named of micro operation. Micro operation. Okay. So it is basically one atomic task or functional task that it will take the help of processor. Okay. It will store its data in temporary processor registers. Okay, for temporary purpose, and perform very small tasks. Okay, these micro operations. Okay. So have you got the idea of this new concept? It is micro operation. Do you have any question on it, or any other query regarding this micro operation, regarding its definition? Operation. Do you have any question? Okay. If you don't have any other question, then I could give the operation, the name of micro operations, or steps in micro operations, how this fetch or indirect or execute or interrupt these phases or these subcycles are performed using different micro operations. And now I have already said that these micro operations are what? It will take help from the microprocessor to be executed, and also it will store its data temporarily in registers. And you know what are the registers inside, and they are used very frequently One is MAR, and there is MBR, then PC and IR. Okay, it is used for what? Memory access. That is, they are placed between processor and memory. PC is indicating the next instruction address, and IR is storing the current address being executed. Okay, current instruction being executed. Okay. Okay. Now, what do you think? If I want to perform fetch operation, what would be my first task? What would be my second task? What would be my third task, fourth task, fifth task, like this, so that each task could be mentioned as a single micro operation. What do you think? What is the first task of fetch operation or fetch cycle? Okay, this fetch operation will be started, or it could be initiated. It could be initiated before any micro operation. How it could be initiated? With the value of PC. You know, when its previous instruction is executing, then its PC is indicating the next instruction. Now it is the phase operation or phase step of this address instruction. Addressed instruction. Okay, so when I am going to phase the instruction, desired instruction, I will follow the content of PC. But this PC is already updated in the previous instruction cycle. So this PC address is holding the address of next instruction. Now, it is fetching what? It is fetching instruction. I know its address. So what should I do? So I should fetch that instruction using the address. And this address is basically pointing one location in main memory. So how could I access main memory? With the help of MAR and MBR. So what do you think? This address will be sent to which register, MAR or MBR?
MAR, sir. MAR.
MAR. Okay. This MAR will now take the value of PC. Okay. Then what is next? So it is one micro operation. And next step is your processor or your control unit will give the command of read command to the memory, main memory. Okay, so that this read command basically change the content of MBR. How it will be changed? That your memory of what? Memory address content will be sent to the MBR. Memory address, that is this address, MAR, will be used in this memory to find out the correct location, and from that located area, the content will be sent to the or copied to the MBR. So it is the read command, but this read command will be reflected in this way. Is it clear? It is the command, but this command will be reflected or visualized in this way. Is it okay? That control unit has given the read command to the main memory, and main memory has updated MBR content. Do you have any question? How they are related? It is basically single step, single micro operation. Okay, if it is clear, what do you think? What is your next step? We have performed this task, we have performed this task. What should be the next? Okay. You know, PC is doing what? PC is indicating the next instruction address. So that address is already sent to the correct place. So is this PC valid? No, because that content is already used. So I need to change the PC or update the PC content. Okay. How is it possible? Do you have any idea? PC will be PC plus 1 or length of unit instruction. Length of unit instruction. So it is your task number 3. So what is task number 4? So you know MBR is containing what? Your current instruction. But if your instruction is inside MBR, is it possible to execute that one? Or I should move it to the another register? If you want to execute one instruction, that should be sent to another register, isn't it? What is the name of the register? Okay.
Sir, IR.
IR. MBR content should be sent to the IR. Okay, so it is done. So each of your step is basically indicating a single micro operation. So 4 micro operations are there to complete your fetch cycle. Okay. So if I show you how the things are changed in register level, can you see that it is before your phase cycle. So when your phase cycle is started, basically it is your first step. It is your first step. So your PC will be copied to MAR. And your next step is your control unit will give the command to the memory. So your MBR will be updated. And when your MBR is updated, MBR is containing your instruction. So that instruction should be copied to IR. Is there any other chance? You can see your PC value is 100 at the last position, 100 at the last position, but here it is 101. 101. The PC automatically, it is not automatically, ALU basically update your PC content by 1. Okay, and you know ALU is doing what? It will perform arithmetic operation. This incrementing is your arithmetic operation. So this is updated with the help of ALU. Okay. So if I give time sequence, okay, it could be T3, it could be T4 at the very beginning. So here you can see this is sent to MAR, memory content will be updated in MBR, PC value will be incremented, and MBR content will be sent to the IR. Now one thing, if it is possible to perform 2 or more micro operations to be performed at a single time. Okay, it is basically what? Defined timestamp, isn't it? So one thing it could be happened that instructions could not be executed in sequence. We have already seen it in what? Pipelining. They could be executed in parallel. And in this parallel execution, so some sequence could be broken. Okay. So this sequence basically controlled by your control unit. Okay. And when you are breaking the sequence, sometimes it could be happened. Okay. Defined micro operations could be executed at the same time. One condition is there that they will not produce any wrong result. That means that dependency should be maintained properly. Okay. Here you can see in this figure, this operation, that is your memory content is updated in MBR and PC value is incremented. So is there any dependency between these two? The answer would be no. So at that time, you could perform them at the same time. Okay, is it possible to execute all these three at the same time?
No, I think.
No. Why? Because here you are updating MBR and here you are sending MBR content to the IR. So at the same time, you cannot perform two operations where the same location is involved. Okay. Okay. If it is indirect cycle. So what is indirect cycle? That means you are using one address from your instruction. It is your instruction. It is your opcode. It is your operand. Operand one, for example, is operand two. So what is indirection or indirect cycle? That some operands could use indirect addressing mode. That means these addresses are not indicating the operand. Rather, it is indicating another address, another level of addressing. So this address is indicating one location that contain another address. And this address could be indicating another address. And lastly, if it is your effective address, of course, your effective address indicate your actual operand. So if your operand is not locating the effective address, that means there are some indirect steps up there. And when it is indirect steps they're involved, then you have to access main memory multiple times. So to access the main memory, you know one information, that is your location. So from where I could get the location? From this instruction. So where this instruction is stored, you know it is IR. So some bits or some one portion of your IR will be used as your address to access the main memory. So how could I access the main memory? Again, I need to help of MAR. So MAR will contain this address to locate your position, desired location. Then that content could be address, could be your operand. It could be decided by your CO that what is it. Okay. So how could I access the content? Through the MBR. Okay. Okay. But before that, I need to update the MBR from where? From memory. Now this MBR content will be updated inside this location. Okay, that means this location will be updated by this content. Okay, for example, it is holding A, it is holding B, it is holding C, it is your operand 5. So after performing several indirection steps, okay, lastly it will indicate or it will contain memory address C. It is your effective address. Okay. So at the last step of this indirection, this C will be updated inside this instruction. And instruction is stored where? In IR. Is it clear or are you confused still? Okay. If you are clear about this idea, I think this time stems will be clear. Time sequence. time sequence. So at the first time, you can see the content of IR, that is containing your address, will be sent to the MAR. Memory content will be updated in MBR. Then MBR content will be sent to, or it will update the address, operand address of the instruction, what is stored in IR. So it is your what? Indirect cycle. Okay. So same thing could be happened for interrupt cycle. What will be first? What will be the first step, or what will be the first micro operation in interrupt cycle? Okay. Your first step will be context switching. That means what is the current scenario of your microprocessor inside? That environment should be stored in a system stack. Now, what is the address? That address is only known by your control unit. What is the address of this stack? So, for example, I will only store or save the PC content. That is my part of your context switching. It could be broad, it could be elaborate, no problem. But if it could be simplified with storing only PC content. Okay. So PC content at the very beginning should be stored where? Where? Your MBR, because now you have to access this memory. Access this memory to access this stack. Now, where I should store? I need an address. So that address will be known by MAR. But who will update this MAR? Control unit. Okay. So control unit will send a save address, and that will be updated inside the MAR. Okay. So memory will be updated from MBR. What is remaining? The thing is that it is not showing that to start the interrupt, to execute the interrupt handler. So what you will jump? And it will be jumped through the PC. So PC value should be updated. So it is your ISR address. And also this address will be sent by control unit. Okay. And if any microoperation could be performed simultaneously, they could be grouped. Okay, if there is no dependency. And here, if I show, these are the three time steps and 4 steps. Okay, now you could ask me, okay, what could be the time sequence for any execution part? The thing is that it is complex because there are different kind of operations. So different operations could lead the time sequence in different ways. So there are some sample ideas that how could this execute cycle could be performed. Okay, very basic idea is if I want to perform add operation. Okay, how could I what should I add? Here your ALU perform add operation between 2 content. One is from register and the is from memory. And you know, this memory address part of your instruction should be sent to the MAR. Memory content will be updated inside this MBR. Then MBR content, R1 content will be added and R1 will be updated. Or if I give another example, for example, it is one kind of branch instruction. Branch. I need to increment. Then if X is 0, X content is 0, X is basically one address, X content is 0, then I will skip X plus 1. Okay, x plus 1. Okay, here you can see this x part of your IR will be sent to the MAR. So what this x is containing, that value will be stored in MBR. And it is what? Increment. So MBR content should be added by 1. So MBR is updated. Then MBR should be stored back to the same position, x. Okay. And that x is basically already held by this MAR. MAR is already holding that position. So using that address, I will send this MBR content to the memory. Now, I have to check this MBR is 0 or not. If it is 0, I need to skip the next instruction. How? PC content is already indicating this x plus 1. I need to increment it once more. Okay, so now PC, if it is 0, PC will indicate this instruction. Okay. If it is call, but function call, if it is a function call. So before function calling, you have to save the current context. So for example, my current context is only PC. So PC should be moved to MBR, and from MBR, it will be stored in the memory. Okay, memory, which location? In this location. So that location will be stored in the MAR. So your PC value is updated. Sorry, PC value is stored. PC value is stored in this X location. Now, this subroutine, this procedure, this function will be started from x plus 1. So is PC equal to this one. PC is already holding the value x plus 1. It is your next instruction from your new function. Okay. X is the address of your new function, but its actual instruction is started from x plus 1. So you may ask me, so what is the necessity of x itself? This x is basically storing your returning address. PC is your previous PC. Okay, before executing this BSAX branch instruction. So what is this instruction? That address is stored by PC now. So that PC will be stored in this X. Okay. After this address X plus 1 is holding your actual instruction of new function. So when it is returned, so why it will be returned? Using the content of X. It is holding the previous content of PC. Okay. Okay, now we have basically discussed about different cycles like fetch, then what? Indirect, execute, interrupt. Okay, but now we should merge them. So how could we merge them? In this figure, you can see like this way they are merged. But the thing is that they should have defined a state. Okay, so here two bits are used to differentiate their different states with unique ID. 00 for fetch, 0 for indirect, 10 for execute, 11 is for interrupt. Here you can see my first step is fetch, isn't it? Now, okay, this is basically, and this value is kind of variable. So what is the name of this variable? ICC. Here you can see ICC. ICC is what? Instruction cycle code. What is the current state that will be stored in the ICC? Okay. So I have to check the ICC to make the decision. Okay, what is my next state? So if my ICC is 00, that means my current state should be fetch instruction. Okay, I will fetch instruction. Then I will check if there is any indirection or not. Any address of your instruction is indirect or not. If it is, then I should use the next state at 01, that means indirect, or if it is not, then I have to perform the execute operation. It is 1 0. Okay, it could be 1 0 1, it could be 1 0. If it is 0 1, okay, I will perform the memory access multiple times. Then when it is finished, then I have got the effective address. Then I will update the ICC value to the 1 0, that is execute. And you know, there are different operations based on the opcode. You have to perform different execution part. Then you have to check the interrupt. If it is yes, then you have to update the ICC file as 1 1. What is interrupt? If there is no interrupt, okay, it is another phase from the next instruction. Okay. Okay. So what is the main task of control unit? It is basically make the sequence of defined micro operations and give the correct command at the particular component. Okay. So if I show you the block diagram of control unit, you can see there are several interfaces. From this interface, you could see instruction command is given to the control unit based on what it will produce the correct command. Okay, for example, if instruction is add, so this control unit will give the add command to the ALU like this. Also, it will get the current status, okay, current environment through this flags. Also, control unit will receive different signals from outer world, not the outer world, outer components. For example, interrupts. Okay. Also, to make synchronization, it will check all the clock pulses. Okay. After that, when it is producing the commands, some commands will be inside the CPU and other commands will be outside the CPU to the system bus, so that other component what is connected to the system bus will get the correct command. Okay. And here the proper address will be also generated through the address bus. Okay. So when your control unit is producing signals, so some signals are produced to activate ALU, okay, or to what? To send some data stored in different registers. Also, it could give different commands to the outside the CPU, okay, to the main memory, to the input output devices. Okay, so I think okay. Basically, your computer system is made of electronics. Okay, and electronics is nothing but a complete circuit. Okay, here you can see defined block. Sorry. Okay. Several rectangles are there. They are basically your different logic unit or your registers. Okay, and they are connected. And you can see there are different points. These are the decision point. If the commands are given to these points correctly, they will open the gate, make the path, so that the command will activate this path and data could be traversed. Okay, for example, okay, I want to perform what? Fetch operation. What is fetch operation? That MAR will be updated from PC. Then MBR will be updated from memory. PC value will be updated by 1. Okay. And IR will be updated from where? MBR. Okay. Okay, how is it possible? How is it possible? You can see MAR value will be updated from PC. MAR value will be updated from PC. So I have to give correct command here so that PC content will be passed to MAR from this register to this register. How is it possible? Control unit will give the correct command in sequence. So CT will be the first command. So that PC content will be sent to the MAR. Okay, what is the next? Memory element or memory content will be copied to the MBR. So what should be my command? C5. So after C2 command, not simultaneously, it should be serial. After C2, it would be C5 command. Signal. It is not a command. You can say signal. And what is signal? It could be 1, it could be 0. Here you can say C2 equal to 1. Here you can say C5 equal to 1. When they are 1, that means C2 is giving the correct order. And when C5 equal to 1, then that means this logic gate is giving the true result or true output. That means it is true. It is true. Now when C5 equal to true, then memory content will be updated to the MBR. So C5 is finished, or these two tasks are finished. Okay, in the meantime, PC value will be updated. Okay, here I have to take the help of ALU. It is not shown in this figure. Okay, after that, what is next? IR will be updated from MDR. IR will be updated from MBR. So I have to give next command C4. That is C4 should be 1. So when these commands are given in this sequence, that means it is completing what? Fetch operation. Similarly, same sequence could be given for indirect cycle, then execute cycle, then interrupt cycle. Okay, like this way, one instruction will be executed in sequence. In that case, you can see how they are connected. They are scattered. All the elements are scattered, and that is the connections how they are made. It is shown here, but normally they are connected basically in this way. Okay, with the central internal CPU bus. Okay, but it is simple. It is simple. But when you will look at the real life CPU, where all the components are connected to registers, ALU control unit, it is look like this one. Is there any question regarding this thing? That is the end of this chapter, control unit. Do you have any question? Okay. So if there's no question, I have another thing remaining from previous chapter. That is we have discussed about what? Pipelining. Pipelining. It has different limitations. One is resource, and there is dependency. It is called data, and another problem is control. Okay, they are named as hazards. Okay, so we have discussed about resource hazard. We have discussed about data hazards. So one is remaining, that is control hazard. What is control hazard? That is basically when your processor is making wrong decision, and this is basically regarding the address of the next instruction. And when it will be happened when there is some instruction regarding branch. Okay, and when it will be branching, if there's any condition, for example, it is condition, for example. So if your condition is true, it will follow this branch, this address, for example, this address 1. If it is false, it will follow another address 2. Or it could be any kind of unconditional branch, where it could be branch to A3, for example. When it is encountered, your processor must follow this address A3 to jump over there. Okay. So what is the solution to solve this type of problem? That is, you will branch correctly, or you will predict the branch correctly. What are the ways? Okay, there are several approaches. Uh, there are several approaches okay, first one is very brute force one. Okay, very intuitive one. That means your processor is very strong, very powerful. It could execute a lot of instructions at a time. And for that reason, you are introducing pipelining. So when you are getting this type of condition, this type of branching, and you are not, when you are fetching the instruction, and perform the decoding, still you are not uh, what you are not ensured that okay, which path you will follow, either A1 or A2. So when you decided, when you have performed, okay, after some subcycles, when you have performed execute phase, at that time you will decide, okay, I will follow only A1. I have to discard A2. Or it could be you are following only A2, you are discarding A1. But before execute part, execute operation, so there are several sub stages or stages in your pipeline. So what would be the scenario for that kind of stages? So here, this approach, intuitive approach, it is saying that okay, I will lead multiple streams. That means I will run this one and this one at the same time. Okay, and when it is producing a result, I will store it temporarily. For example, result 2, it is another sequence and it is producing another result 1. But which result I will consider when I will encounter this execute stage, perform this one. Okay, it will decide, okay, either I will follow A1 or A2. Okay, when I will decide, okay, if it is A1, I will not go through that all the subsequent instructions. Readily, I will use the result R1 because it is already executed. The result is already produced. Or if it is A2, if it is decided, then I will jump to the result directly. Okay, that means that all the underlying instructions are already executed. Okay, I have their results. I have multiple results in my hand, but which result I will follow, that will be decided in this execute stage. Okay. But thing is that there are some limitations because if there is multiple nested branching, okay, at that time this approach will fail. Okay. Next steps or next approach could be prefetch branch target. Branch target means branch instruction. That means after performing this branch operation where it will jump, okay, it is another instruction, isn't it? So this instruction is named as branch target. So I know I have faced one branch instruction, and I know from this decode part, it may follow A1, it may follow A2. Okay. According to this approach, it will only preface this instruction, the first instruction, what is indicated by A1. Also, it will preface the instruction what is indicated by A2. Just this. It will not calculate this one. It will not calculate this one. It will not produce R1. It will not produce R2. Only it will preface the instruction indicated by A1 and A2. Okay. After performing this execute part, it will decide one address. Okay. It will fix one address. It could be A1 or it could be A2. Which one is decided based on that one? Based on that decision, you have the first instruction ready. Okay. During that time, you will update the PC and readily you will follow that path. Okay. And another yeah, right, strong approach could be loop buffer. It is kind of cache. Okay, that means this will only temporarily hold all those branch instruction inside this cache. Okay, as it is a what, very what should I say, speedy memory. So before executing the any branch instruction, before executing any branch instruction, it will just look at this buffer. So is this instruction already executed earlier or not? For example, it is what, branch X. So I will check this branch X is already executed earlier or not. Okay, if it is already executed, you know what is its target address. So that address you will follow. That address you will follow from the next instruction. Okay. So it is your prediction. It is your prediction. Okay, it could be wrong, but it is kind of experiment approach. So it has higher accuracy, and it is already observed that it is producing 75% accuracy to follow the to make your prediction successful. Okay, where they are basically 50-50 chance. Okay, and another more powerful approach is branch prediction. Here you have to use what, history. Okay, some history is static. For example, all the time you could branch, or all the time you will not branch. Okay, or sometimes based on the opcode operation name, you will decide you will branch or not. Okay, you will jump to the next instruction, jump to the new address or not, or you will perform sequentially. You will execute all the instructions sequentially. There are two ways you could follow. That if there is any branch instruction, for example, branch X, you will follow this instruction to jump to the new address. Or if it is false, then you will execute sequential. That means you are following PC content. You are following PC content. That means there are two indications. There are two paths. One is indicated. One is what, driven by PC. It is sequential. Another driven by X. It is jump. Okay. And last one is delayed branch. And here it is basically task of control unit that will basically what, make some delay up to your execute part, up to this execute part. Okay, so when this execute part is finished, then it will decide where it will go. So what would be the task in this time for your pipeline? So then your pipeline basically fetch some save instruction from the subsequent part. Okay, that means that if you do not follow this branch, okay, that means these instructions will not be hampered. Okay, your control unit will find out those type of save instruction from your program, and that would be executed up to this execute part of your branch. Okay, and from this execute part of this branch, if it is executed, then you are sure where you will go. That is which path you will follow, A1 or A2, or you can say PC or X. PC means what? You are going sequential or you are jumping. Okay, there's a thing you can decide when you have executed that branch instruction. Okay, and up to that time you will execute some save instructions. Okay. So regarding branch prediction, the fourth step or fourth approach, there are some prediction I have already said. They are a static decision. That is, always you will perform branching or not branching, or what, based on opcode. They are static. Some are dynamic. Okay, that means you are storing the history, actual history. And they could be stored by any table. Based on table, the table is updating all the time. Based on table, you could find out, okay, if I follow a particular branch address, should I follow the branch address or not? It is branch instruction. Based on this table, you will check out, you will find out this branch instruction. Okay, so what it is telling you? Okay, is it branch or not? Okay, based on this history, you will decide. Okay, or it could be some bits, single bit, double bit. Okay, using these bits also you could store the history. Okay, there is a process written in your book. You could follow them. Do you have any question? Okay. So from this book, I have covered different chapters. And different chapters basically covering different components of your computer system. Still, I hope I couldn't cover all the components of your computer system. Okay, I apologize for this uh, for my shortcomings. I think in future you could cover those things by yourself. I hope the best. But what is your examination? What is the syllabus of examination? Okay, basically we have covered up to chapter 20. Chapter 20 is control unit. Okay. Before chapter 20, we have skipped chapter 17, 18, 19. How should I write these things? Do you have another suggestion? I have chapter 1, I have covered chapter 2, 3, 4, 5, 6, 7, 8. Isn't it? Chapter 9, have we covered?
No, sir.
10, 10
From chapter 12.
chapter 12. Okay. From this book, chapter 12. I have already shared this book in the Google Classroom. It would follow. Then chapter 13. Then instruction cycle, instruction pipeline. 14. Control unit is the last. What is control unit? This one. Chapter 20. So these are the chapters I have covered so far in this course. And also I believe it is not all regarding computer system. But thing is that what would be the syllabus of your semester final examination? So I have covered the chapters 6, 7, 8, 12, 13, 14, 20 after mid examination. So these are the chapters before mid. And I have partially covered chapter 6 in mid syllabus. So there must from here you could expect up to 4 set questions. 4 sets question within 6. So 6 sets question, 150 marks, 3 hours. Exam on 15th December, afternoon. Okay, then other two sets from which chapters? Okay. I think I could discard chapter 1, chapter 2. Chapter 1, chapter 2 from this final semester. Basically 3, 4, 4, 5, 6, they are related because they are related to memory. And 3 is basically what? Generalized idea of computer system. Okay.
Sir,
Yes,
স্যার
please.
3, 4, 5 টা স্কিপ করে আমাদের 6 থেকে 20 পর্যন্ত রাখা যায় না ফাইনালে?
From 6 to 20. That is discarding 3, 4, 5.
ইয়েস স্যার।
Is it possible to make 6 sets question from these chapters? The thing is that I think you have already given the mid examination from these chapters, isn't it? That means you have some idea from these chapters. So if some questions are appeared from these chapters, it will be easier for you to give the answer because already you have that preparation. And if you are following only this, depending on only these chapters, they are completely new to you, isn't it?
স্যার অ্যাকচুয়ালি এত আগে পড়া হয়েছিল এই জিনিসগুলো এখন পড়লে লাইক পুরো শুরু থেকেই রিভিশন দেওয়া লাগবে, শুধু একটু মিডের পরের গুলো দিলে ভালো হতো।
But it is 150 marks. So if I only cover this thing, that is the 4, 5, because they are actually related to memory and discarding 3. Is it okay? I am requesting only include 4 and chapter 4 and chapter 5 with the semester, sorry, after mid syllabus.
স্যার শুধু হচ্ছে স্যার এই মিডের পরেরগুলা থেকে
I have got this
করলে
idea.
ভালো
I
হয়
have,
স্যার
I have, I
ব্যাপারটা।
have got this suggestion, but I am requesting to include chapter 4 and 5.
স্যার 4 and 5 স্যার অনেক বড়।
Huh? Chapter 4
Sir,
is what? Cache memory. Chapter 5 is internal memory. Cache memory is what? Only the 3 functions, the mapping functions, and some defined ideas or concepts regarding cache. And then internal memory is what? What is internal memory? There is Hamming code. Then what? What is important from chapter 4? From internal memory. Is it very big for you? Chapter 4 and chapter 5 with self-final examination.
স্যার সব মিলায় স্যার সিলেবাস বড় হয়ে যায় আসলে।
The thing is that if you are only focusing after mid syllabus, then I need to make some questions in depth because I have to set 50 marks question from each chapters, 6 and 6, 7. 6 question from 7 chapters. That is, some questions would be in depth. So are
স্যার
you
আপনি স্যার
ready?
মিডের খাতাগুলো একটু দেখেন স্যার, এরপরে বুঝবেন স্যার অবস্থা কি আমাদের।
ভাই আমার আশা তো করো না ভাই এখন।
স্যার ইটস ওকে 4, 5 থেকে 6, 7, 8 থেকে 20 enough.
If you all agree, before mid only 4, 5, and after mid 6, 7, 8, 12, 13, 14, and 20. Okay, one thing I will suggest you, that, okay, so some questions are very short. How could I identify these short questions? Based on the numbers, based on the marks, isn't it? And some questions are elaborate or broad question. Okay, I also decided from the marks. Broad question is somehow you are actually telling one story. Okay, how this event is occurred in different steps. But when it is short question, there is no necessity to present a story. You have to just give the answer appropriately that is asked. But you are giving a long story to secure, for example, 5 marks, at most 5 marks. I think it is not wise to manage your time. You are writing one story to achieve 5 marks. Okay, you could achieve 5 marks. You could score 5 marks, no problem. I could identify the answer from the story, but you are basically killing your precious time. Isn't it? So my suggestion will be that find out the question at first and also the marks. If the marks is allowing you to make the story, okay, you can go for the story. But if it is lower marks, up to 5, that means it is asked appropriately or exactly the answer. To solve that particular problem, what should be your approach? Is it clear?
Yes, sir. স্যার একটু কোথা থেকে প্র্যাকটিস করা যায় এটা বললে একটু ভালো হতো।
Main practice book will be your previous year's questions. Okay. Previous year's questions, then exercises. But also you should know what and about from your textbook. Okay, because some questions will be appeared or taken very basic from the concept. If you know the concept, if you know the basic things, how it has happened, I think you could give the answer appropriately. Those questions on, I think they are not from your exercise books, they are not from your previous year questions, but they are from your text. Okay, whatever I have discussed in the class, in the lectures, I have basically taken the questions from those lectures.